Every day, the surface of our planet changes. Cities expand, forests disappear, crops begin to struggle, military equipment moves, land in war zones changes, wildfires spread. Most of these changes happen far from the people who need to know about them. But what if you could photograph almost the entire planet every day? And what if you could take those images, compare them with more than a decade of history, and use AI to identify what changed automatically? That's exactly what Planet Labs has been building for more than a decade. Planet Labs operates the largest commercial fleet of Earth observation imaging satellites. But describing Planet as simply a satellite company misses the most important part of the story. The satellites are only the cameras. The real product is the data. They are building what could eventually become a searchable, continuously updated digital record of the Earth. One that governments, farmers, insurance companies, energy producers, and intelligence agencies can use to understand what is happening across the world. Planet was founded in 2010 by three former NASA scientists, Will Marshall, Robbie Shingler, and Chris Boschwiesen. At the time, the satellite industry was dominated by a traditional model. Build a small number of extremely large and expensive satellites, spend years designing them, and expect each spacecraft to remain operational for a very long time. Planet approached the problem differently. Inspired by the rapid iteration of the software world, they asked a simple question. What if we treated satellites more like smartphones, build them smaller, cheaper, and in large numbers, then launch them often and improve with every generation? They started in a garage in California. The first satellites, called Doves, were roughly the size of a loaf of bread.
This is not the scale model. This is the real size. It's 10 by 10 by 30 centimeters. It weighs 4 kilograms. So that even though this is really small, this can take pictures 10 times the resolution of the big satellite here.
In 2013, the first two went up. By 2014, they were deploying flocks of them from the International Space Station. The difference was massive. A single Planet Labs Dove costs less than $200,000, and it is 1,000 to 3,000 times cheaper than a traditional Earth observation or communication satellite. But the value of these satellites doesn't come from each Dove individually. It comes from operating a large, coordinated constellation. Because they were smaller and less expensive, the company could update the technology more frequently. Each new generation incorporated lessons learned from the satellites already operating in space. That gave Planet a development cycle that looked more like a technology company than a traditional aerospace contractor. But unlike what most people assume, Planet was not initially trying to capture the sharpest possible image of one location. It wanted to photograph almost all of Earth's landmass every day. In February 2017, Planet launched 88 Dove satellites on a single rocket. That brought the company's total constellation to 149 satellites and gave it the scale required to pursue daily global land imaging. This fundamentally changed the Earth observation model. Traditional satellite operators usually waited for a customer to request an image of a particular location. Planet collected imagery systematically, whether or not a customer had already requested it. That difference matters. Its core product is not a single high-resolution image. It's a continuous stream of data. Every day, the constellation adds another layer to a growing historical archive. That archive now stretches back more than a decade and covers the entire planet. But they didn't stop there. Planet also expanded through acquisitions. In 2015, it acquired Blackbridge and the Rapid Eye constellation, adding customers and a historical archive of imagery. And in 2017, it acquired Terabella from Google, gaining the SkySat high-resolution constellation. This gave Planet two complementary capabilities. Its Dove satellites could monitor wide areas frequently, while SkySat could examine selected locations in much greater detail. Planet's business can be understood through three major data layers. The first is PlanetScope, powered mainly by the company's SuperDove satellites. PlanetScope is designed to monitor extremely large areas at a near-daily frequency. Its imagery is not intended to identify an individual person or read a license plate, but it can observe changes in crops, roads, buildings, forests, mines, and infrastructure. Think of PlanetScope as the wide-angle camera, A customer can monitor thousands of farms, an entire country, a pipeline network, or a large forest without manually requesting every image. This makes PlanetScope particularly valuable when frequency matters more than maximum resolution. For example, a farmer may not need an ultra-sharp image of one plant. The farmer may need consistent information about how thousands of hectares are changing every few days. The second layer is high-resolution tasking. This business was historically supported by SkySat, but Planet is now deploying its next-generation Pelican satellites. Pelican is designed to capture detailed imagery of selected locations multiple times per day. The long-term objective is to analyze images on board the satellite and transmit the most important information first, reducing the time between capturing an image and delivering an insight. Planet calls the combination of its monitoring and tasking capabilities tip and cue. While PlanetScope monitors a large area and identifies where something may be changing, Pelican can then be directed toward that location for a closer look. In short, the wide-angle system finds the change, and the high-resolution system investigates it. The third layer is Tanager, Planet's hyperspectral satellite program. Traditional optical satellites record a limited number of visible and near-infrared colors. Hyperspectral sensors divide reflected light into hundreds of narrower bands. This can reveal information invisible to the human eye. Different gases, minerals, plants, and materials interact with light differently. These spectral signatures can help detect methane emissions, analyze vegetation, monitor industrial facilities, and potentially identify certain minerals. Tanager is still an earlier stage business, but it adds another differentiated layer of information to Planet's platform. Planet does not simply deliver individual image files. Its data is distributed through APIs, cloud platforms, analytical feeds, and software tools that customers can integrate directly into their existing systems. This means an agricultural company can automatically receive updated crop information. An insurer can assess properties after a natural disaster. A government agency can monitor ports, borders, or military facilities. Also, Planet has also expanded into satellite services. Under these agreements, governments and strategic customers can pay Planet to build, launch, and operate dedicated satellite capacity. This allows countries to obtain sovereign Earth observation capabilities without building a complete satellite program from the beginning. But Planet's most important asset is not any individual satellite. It is the historical dataset created by the entire constellation. For more than a decade, Planet has systematically collected images showing how the physical world changes. A competitor may be able to raise money, build a satellite, and launch it into orbit. What that competitor cannot do is travel backward in time and recreate Planet's historical archive. That history allows customers to answer questions that cannot be solved with one image. Because one image gives you a snapshot, a time series gives you a pattern. The value of this archive could increase significantly as AI improves. Historically, an analyst had to inspect large numbers of satellite images manually. AI models can search the archive, compare different periods, and highlight unusual activity automatically. Planet is developing tools that allow users to query its archive using natural language, conduct time series analysis, and produce automated reports. This represents an important evolution. Planet is trying to move from selling pixels to selling answers. Instead of giving customers thousands of images and asking them to find the change, Planet wants its platform to identify the change and explain why it may matter. This could make Planet more deeply embedded in customer workflows. Once an agricultural platform, intelligent system, or infrastructure monitoring application is built around Planet's historical archive, replacing Planet becomes more difficult. They don't dominate every category of Earth observation. While some competitors specialize in extremely high-resolution imagery, others focus on rapid revisits over a smaller number of locations or use radar satellites that can collect data through clouds and at night. Planet's advantage is its combination of frequency, global scale, historical continuity, and integrated analytics. In short, it doesn't need to win every imaging category. It needs to remain the most useful platform for customers trying to understand how large areas change over time. Now, let's talk about the numbers. The largest near-term growth engine for Planet is government and defense demand. Planet has secured contracts with the United States government, NATO, and several international customers. Its services support maritime monitoring, vessel detection, military awareness, disaster response, and high-resolution intelligence. Recent examples include agreements with the Swedish Armed Forces, a major German government program, and the earlier $230 million partnership with Sky Perfect JSAT in Japan. These deals are larger, longer duration, and help fund the next generation of satellites. In fiscal 2026, Planet delivered $307.7 million in revenue, up 26% year over year. In the most recent quarter, revenue accelerated further to $94 million, up 42%. Even more interesting is the backlog. At the end of the year, it stood above $900 million, up nearly 80%. Of course, there are risks. Planet has made considerable progress, but this remains a high execution investment. The first risk is profitability. Planet achieved positive adjusted EBITDA and free cash flow for fiscal 2026, but quarterly results remain volatile, and the company is still reporting losses. The second risk is government concentration. Defense and sovereign customers are driving much of the current acceleration. These customers can provide large, long-duration agreements, but government procurement is unpredictable and contracts may contain cancellation provisions. Planet Labs began with an ambitious idea. Instead of photographing one location occasionally, photograph almost the entire world every day. The company successfully built the constellation required to make that possible. It then created a subscription platform around the data. Now, Planet is entering its most important stage. It is attempting to transform an enormous archive of imagery into automated intelligence while expanding into high-resolution imaging, hyperspectral data, and sovereign satellite services. The bullish case is not simply based on owning hundreds of satellites. Satellites eventually become obsolete. The stronger thesis is that Planet has created a historical record of physical change that becomes more valuable as the archive grows and artificial intelligence improves. If Planet succeeds, it could become something similar to a search engine for the physical world, a platform that allows customers to ask what changed, where it changed, when it happened, and why it matters. Planet has already proven that it can image the world every day. The next question is whether it can turn that view of Earth into one of the most important intelligence platforms of the next decade. If you enjoyed this video, smash that like button, subscribe, and turn on notifications so you never miss the next fundamentals breakdown. This is for educational purposes only and is not financial advice. Always do your own research before investing. Thanks for watching. I'll see you in the next one.